Okay, we are on the air.
No, but this needs to be addressed. Just make it, and they would know. Especially if they're probably mad. Oh my gosh, I gotta make little brother switch to people.
All right, so let's do another one. All right, so let's say that we have a national number of 90% of people have access to fresh produce. And let's say that in northern Wisconsin, out of 300 people, see if I can make this work. 258. And I want to use the p-value. Okay. Now, it would make 300. That's 86%. So then what I'm going to say is, I'm going to ask the question, is the rate lower in northern Wisconsin? Okay. So I'll give you but I'm going to use alpha 0.01.
300, right?
Yep.
Oh, that's trouble.
All right.
Really strange numbers.
Okay, so do you have 0.86 minus 0.9 on top?
Where the 0.9,
Okay. So are you putting all the numbers in your calculator at once, or?
no, I did negative 0.04, divided by parentheses, where was 0.9, 0.1, divided by 300, parentheses.
Okay, so let me see what you got on your calculator for that.
Well, I take it minus the p hat.
Oh,
Oh.
You have your square root. And then put it inside. Just break it.
P-value would be the point.
Alright.
All right, you might want to check with your neighbor, see what your neighbor's got going on, see if it makes sense, see if it works.
still got really kind of, yeah, make it.
No.
You're taking the area of that V. We're using the same formula, but all we do is this is the area. Okay? This is to the left, which this is telling us.
That's right.
And then you press 2.8. I just, yeah, that's your thing.
All right.
And this-
Okay, so what are the hypotheses here? Okay, and the alternative? Okay, less than 0.9. All right. Donna, what's next in hypothesis testing? Okay, so you should have your list of procedures in front of you. First one is to find the hypotheses and identify the claim. Then what's the second thing would be the next question to ask. Brianna, can you tell me the second thing? That's right. So we don't have critical value here because we're doing p-value. Okay, so then what's the next thing? Test value. Can you tell me what you get for test value? Okay, what'd you get?
Negative 2.31.
Yep, so the test value is negative 2.31. All right, Danielle Koch, what happens next?
Then you move that into
Okay,
and you get 0.01.
0.0104, is that what you said? Okay. Do we need to subtract that from 1? Okay, what does our picture look like? It's a left tail test, it's less than. So then our picture looks like this. Is this the same as the picture on the bottom of the page? Yes, it is. So we don't have to do anything with this. When we look at the 0.0104, which comes off the table, that's the answer for the p-value. So this is the p-value.
I'm sorry, can you go? I'm not getting that. I don't understand.
Okay, the definition of p-value is the area of the tail.
Okay, I think I got
All right,
it.
so it's negative 2.31. So from here, we also know that it's a left tail test. So we're looking for the area on the left. And on the Z table, areas are on the left.
Right.
Okay,
Thank you.
Danielle, does that make sense?
Yeah.
Okay. Casey, what happens, or Casey's not here. All right, Jackie, what happens next?
Then we decide whether or not we're going to reject.
We do, and how do we go about doing that?
We reject it if the p-value is less than alpha.
That's correct. So what do we do here, Jackie? Is the p-value less than alpha?
It's more than alpha?
It's more than
We
alpha,
are not going to reject
so we are not going to reject.
because there's not evidence.
Okay, hang on.
Okay.
The first thing is we make a decision. And that decision is do not reject the null hypothesis. Okay? Because p-value is greater than alpha. Then what was the statement that we make next? If we do not reject the null hypothesis. Jackie, what's the next thing?
I know.
Okay, Natasha, what's the next thing we say after we say do not reject the null hypothesis?
There is not enough
There is not enough evidence to prove H1. All right, Jackie, does that look familiar?
Yeah, that's what I had, but I was confused because
Okay.
that's what I was starting to say and then.
I stopped you. Okay, and so then your lesson for today, Jackie, is you're right.
To take steps.
You're right. You're right about stuff. So say stuff when you're right about it. All right. In this situation, you were right. Okay, Hallie.
So on the test, as part of step 4, if it would be do not reject, do we have to include the no decision and then the random fluctuation? Or are we going to get points taken off of this one?
I hate that phrase. I'll answer it, even though I hate it, but I'll still answer it. Okay. On the test, I will say, should you reject the null hypothesis or not? And then you will decide which one to do. And that will be the question. On another question, I will say, if you do not reject the null hypothesis, what does that mean? And then you will put the rest of the stuff.
So that's not something that you just automatically put every time you say do not reject.
You don't have to.
Okay.
If you were to put it, I would not count it wrong. Because you would have gotten correct the thing that I asked you for. All right. So what else do I say when I say there's not enough evidence to prove something? It could be a random fluctuation also. No decision. Okay. There's not enough evidence to prove this. No decision. It could be a random fluctuation. Okay. So I'm looking at this and I'm asking the question. In northern Wisconsin, they have a rate of 86% compared to the national number of 90%. Is it really lower? The sample was lower, but I want to know if the population was lower. And right now I say there's not enough evidence, no conclusion, could have just been a random fluctuation. However, if you'll notice, my p-value was 0.104. That's awfully close to 0.01 now, isn't it? So if I were doing research, maybe I would put on my research p is equal to 0.0104. So even though it's not technically less than 0.01, it's close enough, all right? Rounding off, it's almost the same. So in research, they will actually put the p-value into the research and then let the person who's reading it decide how important they consider it to be. Certainly, if we had chosen alpha 0.05, we'd be fine. So why would we pick a 0.01? Well, maybe that's not that important. So there seems to be decent evidence that this is a lower population proportion. So it doesn't make a lot of sense for me to say absolutely it has to be this way when it's just 4/10,000ths away from being what I want it to be. That's where experience comes in. That's where the practical application of this, okay, is not as cut and dried as maybe it would be on a homework question. And on a test question, if you were to say, hey, this is really close to 0.01, I think we should probably go with it, I'd say, yeah, I think so too. But if you say, oh, 0.0104, that's greater than alpha, so we got to say we don't reject it, then I'll say, well, okay, that's right. But it's almost more right to say, hey, it's really pretty close here, no big deal. All right, so this is p-value. This is using hypothesis testing with proportions. So now we're going to start by talking about how we're going to review for the test. There are problems in. Okay, so we're not going to do a p-value method. We're going to do all this stuff. We're not going to do hypothesis testing right now. Well, kind of do it, so I'll make this work. So, in northern Wisconsin, out of 300 people, 258 have access to fresh produce. So find the 95% confidence interval. For the proportion. Okay, so this is what we're going to do right now. I'll give you a couple minutes, see if you can make that work. And I'm going to want your answer to be to use 3 decimal places in the answer.
So we do. We're not.
Yeah. 3. Yeah. What you want is to use probably, I guess the short answer is yes. The long answer is, makes sense if you use table F with 95% confidence interval and go down to the bottom.
Good. Does that work with all these confidence intervals?
Okay, this is a confidence interval for proportion. Okay, and yes,
The proportion, you can jump to table F.
yes. Table F and go down to the bottom where it says, talks about the z-score.
Yeah.
That's upper push.
I do this.
Find the angle. When you do
Because I get confused with what. Yeah.
All right, so what's the equation look like for confidence interval?
I had.
Like that. Humphrey, can you tell me what the z-score we're going to be using for this confidence interval? Okay, it's a 95% confidence interval, and we need to know what that z-score is. Natasha, can you tell me what the z-score is for this? 1.960, yes. How do we find that? Great question. Kelly, how do we find that?
On table F, you just look at 95%, go to the bottom.
Okay, if we're looking at table F and we look at confidence intervals, we go over to where it says 95%, we go all the way down to the bottom, 1.960. All right, Humphrey, you see that number? Okay, so that's the z-score we're going to use. Technically, it is the z-score of 0.025 as a tail area. That's not really that important for us right now, as long as we can find it, right? 95% confidence interval, down the bottom, 1.96. So p hat is 0.86. It's 258 out of 300. Put those numbers in there, crunch them. Hopefully we come up with 0.821 and 0.899. Okay, so if I take 1.96 multiplied by the square root of, in parentheses, 0.86.
0.86 minus that.
Well, if you want to do everything in your calculator all at once, then yes, you do 0.86 minus this multiplied by square root of this times that divided by 300.
That's like you just square what done by.
Do a least figure.
Yes. Because it is the square root of all those things multiplied. They have to be multiplied first, then the square root. All right, any other question about those numbers?
Can I see if I get it?
Sure. Go right ahead. Now, some of you have calculators where you can go back into a previous thing, and you can just change your minus sign into a plus sign. Saves you a lot of work.
Where do you put your parentheses in?
I've got it up above the formula.
So it's times instead of-
Mine, I used to calculate like that. Mine.
All right, Natasha, does that work? Okay, so now, this is not necessarily going to be on the test, but if you think about this carefully and you ask the question, what does that confidence interval actually tell you? What is the purpose of the confidence interval? Melissa Peterson, can you tell me the purpose of the confidence interval?
Where the room of error is for the number, so.
Nope, sorry. Okay. You have a few good concepts in there, but they're just not the ones I'm looking for. Okay. Amanda, can you tell me the purpose of the confidence interval? Kelly, can you tell me the purpose of the confidence interval? Tasha?
Use the sample to understand the population.
It's to use the sample in order to actually measure something about the population. Okay, the confidence interval. And by the way, I'm going to ask you that question on the test. And I'm going to ask you this on test number 4. What's the purpose of the confidence interval? And what you should write down is that it is to use the sample to measure something about the population. The fact that I would ask a few of you and you would say that you did not know is a negative thing. Okay, eventually when you see the test in front of you and you have that exact same question, it's really good if you can just write down that answer, because you're going to see it, not just today. You're going to see it on that test. You're also going to see it on the next test, because we're going to be talking about it all the time.
Are you going to do the proportion one too?
Proportional. This is the proportion confidence.
I'm saying like a question like that, like what is the purpose of the probability or whatever, it's measuring percentage.
No. I'm not going to ask you that question. You just be able to recognize when the question looks like that it's a proportion problem. Okay. So if this is what's happening, I went up to northern Wisconsin, I asked a bunch of people, do you have access to fresh produce? They came up with a number of 86%. That's not the correct number, because it just came from a survey of a sample. So then when I asked the question, what is the real percentage for all the people in northern Wisconsin? I say that is between 82 and 90%. That's why the confidence interval gives you more information than a hypothesis test. The confidence interval actually tells you what that number is within a certain range for the population. Now, is that number less than 90%?
86%?
No, the confidence interval. Is the confidence interval less than 90%? So if I find the confidence interval, I could prove the alternative hypothesis, because it's less than 90%, which is what I wanted. So instead of going through that whole thing with hypothesis testing, all those different steps, I could just look at my confidence interval and say, oh, yes, it's less than 90%. That's why people say confidence intervals maybe are better than hypothesis testing, because it gives you more information about where the real number is. And then you can decide, is it less than my national number? Yes, it is, because that confidence interval is less than 90%. Okay, so now let's talk about measuring the mean with confidence.
Where did I put that?
Okay, so let's talk sodium levels. Sodium in food. Let's say I measure Western food. And I do some kind of a really cool thing where I can measure their sodium intake per day. And I find that it has a mean of 30,200. And standard deviation of 300. And there was a survey of 15 students. And I want to know, find the 90% confidence interval for the mean. And answer to the nearest whole number. All right, so the formula you should be looking at is so you might want to check with your neighbor about their procedures here, make sure they're doing it right. Okay, so what I want you to do is to stop working on your thing and look at somebody else's thing and see if that's the same thing as what you got, all right?
So,
Or not, the change.
The what?
Goodness, that's
Yes.
I was like looking at it, and I was like, how did I come up with I didn't think of correct, so maybe that was correct. But I wrote the T.
Oh, yeah.
All right, so, Kelly, you got the number for T here?
2.145.
No. Because my 90% confidence interval is where I'm looking for. And my degrees of freedom is 14.
1.761.
1.761 should be the T value that I need. And then this would be 3,200 minus that, multiplied by 300 divided by square root of 15. And then the same thing with a plus sign in it. Amanda, did you get what you think are right numbers here? Okay, what do you got?
3,064,
Okay,
and then 3,336.
all right, so 3,064. 2,300 and what? 36?
I rounded this down because I thought we were talking about downtown with sodium. We would have rounded up.
Okay, at what point are you talking about rounding off? The lower end, 3,063 instead of 3,064?
Yeah.
Okay. Well, the nearest whole number would be 3,064. All right, any other question about where these numbers come from? Okay. So yeah, it's kind of important that you have the correct order of operations. You're putting the right numbers in the right place in the formula. If you did, as Kelly did, if you made a wrong choice about T, well, that's 1 point out of 5 points on the problem. So knowing where the general numbers are supposed to go is really pretty important. Okay. And if you know where to look on the T table, you're not looking at chi-squared or something weird like that. Okay. Notice, once again, if we were to ask a question, do Western students have sodium levels higher than 3,000 on average? We would be able to say yes, because the confidence interval is greater than 3,000. The number we got certainly is greater, 3,200, but is it significantly greater? And based on this, the answer is yes. Okay. Now we're going to do, using similar numbers, we're going to do the confidence interval for the standard deviation. Okay. So we did the confidence interval for the mean. Now we're going to do confidence interval for the standard deviation. Find the 90% confidence interval for the standard deviation.
So right, if you go down. The degrees of freedom. So it's like 15 minutes. There's 14, so there's 14.
All right, so formula that we need here.
1 minus this. So this would be
So the calculations are not very difficult with this. It's more of a problem finding the correct numbers on the chi-squared table, table G. So to find chi-squared right, you look for alpha over 2 and go down the correct column to the correct degrees of freedom. For chi-squared left, you do 1 minus alpha over 2. Okay. Now, as it turns out, I will give this to you on the exam so that you'll have this formula along with this other piece of information. Okay. So, if it's a 90% confidence interval, what's the value of alpha? 0.1. So, Jackie, you got chi-squared numbers for me?
Right?
23.685 for the right, and then for the left? Okay. Okay, what's the value of alpha, Natasha? 0.1. What's the value of alpha divided by 2? Okay, so if you take 0.1 and you divide it by 2, what do you get? .05, hopefully.
So then the left, would you say 0.571?
It is.
You're saying the right one is what?
Okay, in order to find the one from the right, you take alpha divided by 2. Alpha is 0.10. When you divide it by 2, it's 0.05. So if you go down from 0.5 down 14, you see it's 23.685.
One minus that.
So we take 1 minus 0.05. That gives me 0.95.
You do one minus.
No, you're taking 1 minus alpha divided by 2. If you look up at the formula that's on the board, it's not 1 minus the chi-squared. It's 1 minus alpha over 2. If, however, you just look at your sheet of paper that's in front of you, you should have written down 1 minus alpha over 2. And it's a common problem. People don't remember what thing do I subtract from 1, okay? And so you need to actually look at what's in the formula. It's not 1 minus the chi-squared. It's 1 minus alpha over 2. So if I take 1 minus 0.05, what do I get? 1 minus 0.05 is 0.95. So that's the column that I'm going to look for. I'm in the 0.95 column. I go down 14. That's 6.571. So then when I put those numbers into the formula, my confidence interval is 231 to 438. So 300, which is what the standard deviation I thought was for my survey, that's not the standard deviation for the population. It's just for the sample. So if I want to know what is the population standard deviation for sodium intake for Western students, that population number is somewhere between 231 and 438. All right, that's enough for today for review. Next time we get together, we'll talk sample size, which we didn't talk today, and then also do hypothesis testing for proportions, mean and standard deviation, and p-value. That'll probably be enough. So I'll see you on Wednesday.